Okay, so this next question is another functions question, and we're looking here at a function that looks to be a quadratic. I've got the squared term there, and we're looking at modeling this ball being thrown. So we're going to be plotting this as a function, or as a graph. It's going to be a lot easier to work with. So plotting this down, I have negative 4.8 x squared plus 21x. Now it's t in the question, but I know that when I'm typing it into my GDC, I need to type it in as an x rather than a t. And then I'm going to graph this. Now I can see there it's not quite big enough, so I'm just going to zoom out. There we go. We can see what's happening there. You could also use your window. So I could change this to negative 20 and 20, knowing that I'm not really going to be needing a large x value there. Okay, so that's what my graph would then look like. So the height is shown as the y value, and then the time is shown in seconds on the x coordinate, or at the x-axis. So the first thing to do is to write down the height of the ball as soon as it's hit by the bat. Well, the time starts when I hit it, so therefore I'm looking for this value here, which is where it crosses the y-axis. So as soon as the time starts, what is that value? So I can go into the table of values here, and I can see straight away that when x is 0, y is equal to 1.2. So that's essentially what it's asking me here. When x is 0, what is y? And we can see that it's 1.2 meters. Now, when you're doing this, you should just be a little bit careful in terms of what you're calling your variables. So in this case, it's the height and the time. So when time is 0, what is the height? And it's 1.2 meters. So that's the first answer there. And then the second one, find the value of t when it hits the ground. So when it hits the ground, if I go back to my graph, that's this point here. Okay, so I've hit the ball with the bat, it's gone high, it's bounced, and that's when it hits the ground. So to find that, I'm going to go into second function trace to find the calculations, and I want to find the zeros. So I can go a little bit closer. So that's the left bound. This is the y bound. So I'm just choosing one either side of the point where it crosses the axis. And it finds my value there. So it's when t is equal to 4.431 seconds. Or to three significant figures, it would be 4.43. Okay. And then for the last part of the question, for part C, I need to state an appropriate domain. So an appropriate domain would be between 0, because I can't have a negative time. So I know it has to be above 0, but also the ball can't go underground. Okay, so for this section here, it wouldn't make sense for the model to work because the ball can't just keep falling through the ground to the center of the earth. So it therefore goes up to, and it could include, since that's the point where the ball hits the ground, 4.431. So that would be a sensible domain there for us to pick. So it's 1 mark for each of the domain ends that you've calculated.